Hello everyone, I welcome you all to my YouTube channel. And today we are going to do our 15th question in this series. And the question is candy. So, let's understand this question. So, the question states that there are n children standing in a line. Each children is assigned a rating value given in the integer array ratings. And you are giving candies to these children subject to the following requirements. First requirement is each children must have at least one candy, and the second requirement is children with higher rating get more candies than their neighbors. So what is given in this question is that there is a rating integer array, and based on this rating we have to provide candies to the children, and the condition are that each children get at least one candy. Every children must have at least one candy. And the second is that if a student or if a child has a rating higher than his neighbor, then definitely his number of candies must be higher than its neighbor. So based on this, we have to find out the minimum number of candies we need to have to distribute the candies to the children. So what is the minimum number of candies we are needed? We have to find that. So now let's understand how what is this question and how we should proceed. So here you can see in our first example what we have 102. So let's take the first example, and the example is 102. 102. So what happen is that it means that the first child has one rating, second child is zero, and the third child has two rating. So the first requirement is to at least give one candies to everyone. So let's fulfill that. So we give one candies to first, second to one, and third also get one. Now let's think about the second requirement, which is that if a neighbor has higher rating, then it must gets higher number of candies. So let's start from first point and understand how it's happening. So the first one has a rating 1 and the second one has rating 0. So definitely the first one must have higher number of candies than second. So if you give two candies to the first one and one candies to the second one, then this satisfy because the higher rating student have higher number of candy than lower. Now again when you move to third, you see that the rating is 2, which is higher than its neighbor, and neighbor is 0. So you should increase it. So it also increased to 2. So this is how it is going to be. So our answer is came out to be addition of this, which is going to be 5. So our output is 5. Now this is the situation how it is being going. Now let's understand some other situations to understand. So let's take one example and understand how we are going to solve this question. So we are going to take one example, and the number is going to be 1, 3, and 2, and 2, and let's take one. Okay. So this is example on which we are going to analyze our algorithm. So what is in the here is that we have to satisfy two conditions. The first condition is saying that at every child get at least one candy. So let's first satisfy this. So first get one candy, then one. So all child has got one candies, and first is satisfied. Now we have to think of the second condition, and what it is saying is that if a child has a rating higher, if a child has a, let's assume this, if a child has a rating higher than its neighbor, then it must have a higher number of candies. This is the only condition it wants. It wants to check for every child. It wants to satisfy that. If you can satisfy, then you are able to solve this question. So, if you think how you can satisfy, there are two ways. If you are at any child, you first check at its left one, and you can check at its right one. These are the two, or there is no more options. So, for every index, if you are able to check, then you are able to solve this scenario. Now, how we are going to do? We are going to start in one direction. We are going to satisfy the condition in one direction for every element. So let's start with the right side. We are going to check for every in the right direction. So we are going to check for every element that if its rating is higher than its right one, then what we are going to do? We are going to increase the amount of candies in it. So let's start. So if we are at first index, what you are seeing that the first index and the second index, you are seeing that the second index is higher. So second index must contain greater number of candies than first, and the first one already contains how many candies? One. We are starting from the one because the least we can start is one, so we are doing that and start from the one. So if it is one and as our condition is not satisfied, that means it is greater, then we have to increase. So what is the amount we have to increase? We have to increase the already existing amount of candies for the first plus one. So we are going to do 1 plus 1, which is going to be 2. Now again we are going to check for the next couples, which is going to be this second and third. And what you are going to check that the third one is greater than the next one. So this condition is not come in our scenario, because what we are checking that the next one is greater, because but here next one is less. So if it is this, then we leave and move to the next. So if you move to the next two, here you can see they are equal. There is no higher one, so you will then again escape. Now again you check, then it is less, it is not higher, you again escape. So this is the first part, and in this what you have done, you have satisfied that for every index child, if the right one is higher, have the higher number of points, then it is getting higher number of candies, it is satisfied. Now the next which we have to think is for the left ones. So now let's move from the left side to check for the left ones, because we have moved to the right side to check for the right ones. Now we are going to do same for the left ones. Now we are going to start from this index, we are going to check in these two. So what we are going to do, first we are going to check for this and this. So you will see that the next index is higher. So if the next index is higher, what you have to do, you have to increase. And by what amount? The previous one and the current one. So you can see that the previous one is 2, because here we are starting, so it is going to be 1, because I already discussed that if you are going to start and you want the minimum, you will start with the minimum. So minimum is 1, we will start with minimum. Now second is higher, so what we have decided, we are going to increase by the already existing amount of candies with the first ones plus 1. So it is going to be 2. Now again when you move to this one, you see they both are equal, so there is no change. So you do not have to do anything, it is already 1, so it exists 1. Now again when you check, so when you move to the next, what you will see, you will see that the value is increased. So if value is increased, what we have decided, we have decided to increase the value. So we increase this plus 1, which is going to be 2. Now again when you check for the next one, you see it is decreasing, so you leave it as it is. So what you have done, you have satisfy in this, you have satisfied for the right ones all the neighbor for the right, and in this you have satisfied all the neighbor for the left. This is for the right and this is for the left. And by doing that, what you have done, you have satisfied all the conditions. Now if you take the maximum of both two, what happens, you have satisfied both of them. So if you take maximum, which is going to be 2 1, here 2, here 1, here 2, here 1. So if you are using this amount of candies to each and every student, you give to every student, then you are satisfying both the conditions. So this is the algorithm which has been built out from this. And the important point you have seen is that it is came out from the second condition. So the condition given to your question is very important, think about that carefully, what it is pointing out, because it is here is it is pointing only to check for its neighbor. So we have think of the neighbor right and left neighbors. Now let's code this and understand how it is going to be coded. So what we're going to do, so first let take int l is going to be the length of the ratings. Now ratings dot size. Now we are going to take a vector. So why we are taking vector? Because we have to store the values. Let's take it v and initialize it, and we are going to initialize it. You will see why we are going to initialize it and what is the value. So the value is 1. And why we have done? Because in all situations we have to satisfy first condition, which is minimum one. So we are doing this by initializing directly. Now let's move for the first part, which is going to be the right hand side. Never, right never. So we are going to start from the first index, because you start from the zeroth index, but you have to change the if conditions. So I am starting from the 1, and is going to be to the L I plus plus. So what is the condition in here? We are going to check. So condition is going to be, if the rating I minus I is rating I is greater than rating I minus 1. So if the next one, or you can say the right one, I can also do one thing. I can write here, right, no, right neighbor. So we are checking here right neighbor. So if it is greater than if the next one is greater than the previous one, then what we are going to do? We are going to change the value in the next one, which is going to be vi, to which value? To value vi minus 1 plus 1. So this is the overall we are going to do. In other cases, it is already satisfied, so we are going to escape. Now again, let's do for the second, which is going for the left neighbor. Take int. We are starting from the previous index, which is going to be in L minus 1 to each index I greater than 0 until I minus minus. In here, we are going to check. We are going to check if rating I minus 1 is greater than rating I. So if the previous one is greater than the current one, then what we have to do? We have to increase the previous one, which is going to be vi minus 1. And to which value? To vi plus 1. So here one thing we are going to do here, at this point only, we are going to take the max which we have taken later in our algorithm. So we are going to take the max of this, and we already existed v minus 1 value. So this is the for the right neighbor. This is for the left. So this is the for we have satisfied all the condition. Now one thing we need to do, we have to just calculate the sum. So let's take answer equals to 0, and let's run a for loop for int I equals to 0, I less than L I plus plus, and we are going to do ans plus equals to, and which value vi. So this is going to sum up all the number of candies. Now we simply return ans. Now this is the code. Let's try to run this code. So it is accepted. Now let's submit this code. So it is successfully submitted. So this is a very interesting question, and you've understood how we have to assess any question. So thank you all.